Good evening all. Welcome back to NEET World. This is Swapna, and in last class we have started acids, bases and salts in YouTube live sessions, and in the last class we have discussed what are acids and its characteristics, what are bases, its characteristics, and how to identify different types of acids, bases by using the indicators, right? And after that we have discussed about what is neutralization reaction. See, what is neutralization reaction, ma? When acid is reacting with the base, it results in the formation of salt and water. So here in this class we will discuss about different types of other reactions, and before that we will discuss the types of acids, means classification of acids. See, acids are classified as strong and weak. Acids are classified as strong and weak. If you see, acids are classified into strong and weak. How? Based on what property acids are classified as strong acid and weak acid? If you see here, strong acid and weak acid means, for example, based on strength, it is classified based on strength, ma. For example, if you are taking hydrochloric acid, assume that there are 100 molecules of hydrochloric acid. How many molecules, ma? There are 100 molecules of hydrochloric acid. So in the presence of water, in the last class we have already discussed that in the presence of water, this acid, it will dissociate into its ions, means into its H plus and Cl minus ions in the presence of water, right? So here if you are taking 100 molecules of HCl, then in the presence of water almost like 98 H plus and 98 Cl minus, means almost all HCl molecules are dissociating into H plus and Cl minus, only 2 are remaining as HCl molecules, means almost complete ionization is taking place, right? If such complete ionization is taking place, then we will call it as strong acid. See, here I have mentioned nearly complete ionization takes place. For example, if we are taking 100 acetic acid molecules, what is the formula, ma? CH3 COOH. In the presence of water, what will happen? We will get H plus ions and CH3 COO minus ions, means for example in out of 100 molecules, if you are getting only nearly 48 CH3 COO minus plus 48 acetate ions and 48 what is next one? H plus ions. Then remaining how many? 52. Remaining 52 molecules, it will not undergo ionization, means it will be like CH3 COOH only. It means here only some of the molecules in the presence of water, they are converting into its ions, acetate ion and hydrogen H plus ion. So such a type of molecules, we will call it as, such a type of acids we will call it as weak acids, means partial dissociation, partial ionization takes place. Okay, if complete almost all ions, almost all molecules are dissociating into its ionic state, then we will call it as strong acid. Only partial ionization it is taking place, then we will call it as weak acids. Now see here, this is all about strong acid and weak acid. If we are talking about concentrated solution and dilute solution, what does it mean? For example, more amount of acid present per unit amount of volume. For example, see, take 1 liter. In 1 liter of the solution, more amount of acid is present then we will call it as concentrated solution. Or else in that concentrated solution we are adding some water. So what will happen? In this 1 liter, less amount of acid is present, then we will call it as dilute acid. See here, per unit volume, how much amount of acid is present? Means if it is more, in that 1 unit or 1 liter of volume, more amount of acid is present, then we will call it as concentrated acid. If less amount of acid is present, then we will call it as dilute acid. You may get doubt, is there any relation between strong and concentrated, weak and dilute? No ma, it completely different from each other. We will not say weak acid as a dilute acid, both are different. Here we will consider based on how much amount of acid is present per unit volume, and whereas here we will consider the dissociation of ions. This is all about based on strength how acids are classified, based on concentration how acids are classified. Now here, if you want, here we can take one example. See, for example, in 1000 ml means 1 liter. In 1 liter it means 1000 ml. More amount, if you are taking nearly 600 ml of acid is present. Okay. In another example, in the same 1000 milliliters of solution, only 100 ml of acid is present. Okay. So in the same 1 liter only, in 1 liter it means 1000 ml, 1000 milliliters of the entire solution, it contains 600 ml of acid. Whereas in the second one, in the same 1 liter it means 1000 milliliters, it contains only 100 ml of acid. So which is concentrated and which is dilute? First one is concentrated because it contains more amount of acid. Second one is dilute because it contains less amount of acid. Okay. Then moving to the next one, basicity of acids. Basicity of acids means number of replaceable hydrogen ions. If you see HCl is there, okay, it can donate H plus ion. So we will call it as monobasic. If you see H2SO4 sulfuric acid, it contains 2 replaceable H plus ions. So we will call it as dibasic. Now next one, H3PO4. In these 3 replaceable hydrogens are there na, so we will call it as tribasic. Okay. This is basicity of acids. It means basicity means number of replaceable hydrogen ions in the given formula or given acid. Okay. Then moving to the next slide, classification of bases. In classification of bases also, see, based on strength means based on strength we will call it as concentrated solution, concentrated basic solution or dilute basic solution. We will call concentrated or dilute. Or else what we can say, based on dissociation we can say it as strong base or else weak base. So in the similar, just like acids only, if high amount of base is present per unit volume, we will call it as concentrated solution. If less amount of base is present in the given amount of solution per unit volume, we will call it as dilute solution. Now moving to the strong base and weak base, similar like strong acid and weak acid, similar like that one only. Strong base and weak base means, strong base means complete or almost complete ionization of base takes place into its ions, whereas weak base means complete dissociation will not take place. For example, if you take NaOH, if you are taking NaOH, out of 100 NaOH molecules on dissociation in the presence of water, almost 98 or 99 if you are getting 99 Na plus and 99 Na plus and 99 OH minus ions if you are getting, and only one NaOH is left undissociated, then we will call it as strong base. For example, ammonium hydroxide, take ammonium hydroxide. Okay, we are taking 100 molecules for example. On dissociation in the presence of water, it will dissociate as NH4 plus and OH minus. Only for example 50 NH4 plus we are getting and 50 OH minus we are getting, then what is happening? Complete dissociation is not taking place. Such a type of base we will call it as weak base. Okay, any doubts ma? Clear? Then see solubility. In the last class itself we have discussed that by solubility. See, if some bases are there which are soluble, some bases like sodium hydroxide, potassium hydroxide, they will soluble in the water. Such type of bases what we will call it as alkali. And insoluble bases such as copper hydroxide and ferric hydroxide, they are not called as alkalis because they are insoluble in water. If soluble in water, then only we will call it as alkalis. Now, moving to the next one, acidity of bases. Acidity of bases. See, for example, what do you mean by acidity first? Acidity means number of replaceable OH minus ions. Simple. How many OH minus are there? In NaOH, one OH minus is there. So, we will call it as, what is the acidity? 1 OH. Now, see, monoacidic, we can call it as monoacidic. In calcium hydroxide, CaOH taken twice, here 2 OH minus ions are there. It means 2 OH2 hydroxide ions are replaceable. It means it is diacidic. Next, aluminium hydroxide. How many replaceable OH minus ions are there? 3 replaceable OH minus ions are there. This is all about acidity of bases. So, what we have completed? We have completed classification of acids and classification of bases based on their what is that? Dissociation, how they will dissociate in the presence of water, and also we have discussed acidity of bases and basicity of acids. If monobasic, 1 replaceable ion, dibasic, 2 replaceable ions, tribasic, 3 replaceable ions. Next, moving to the next one. Here I have given some salts preparation methods. See, first one, if you see sodium, 2 sodium is reacting with chlorine gas, we are getting 2 NaCl. In the second one, if you see second one, zinc metal is reacting with sulfuric acid H2SO4, it results in the formation of zinc sulfate ZnSO4, and also we are getting hydrogen gas. If you observe here I have mentioned upward arrow. This upward arrow represents in any chemical reaction, it represents it is a gas. Generally in chemical reactions we will represent, if gases are released, we will represent it by upward arrow symbol. Now here if you observe, zinc is forming bond with sulfate in sulfuric acid and results in the formation of ZnSO4. If you observe only one ion, how it will exist here, sulfuric acid 2H plus and SO4 means SO4 minus 2. So, this one ion is getting bond with zinc, right. So, such a type of reactions we will call it as displacement reactions. If you observe here, what is happening here? Zinc, a metal is reacting in the presence of acid, sulfuric acid, we are getting zinc sulfate and hydrogen gas. Keep it in mind, any metal when it is reacting with an acid, it forms a salt, along with the salt it releases hydrogen gas. Okay, very important reaction. When a metal is reacting with an acid, it results in the formation of salt and also it releases hydrogen gas. Moving to the next one, and this gas we will represent with upward arrow. Moving to the next one, precipitation reaction. Precipitation means in a reaction precipitate is formed. What do you mean by precipitate? Precipitate means an insoluble solid. Precipitate means insoluble solid. So, in any chemical reaction, if a solid is formed which is insoluble, means which is not dissolving in that, then such type of reactions we will call it as precipitation reactions. If you observe here AgNO3, silver nitrate, it is reacting with NaCl, sodium chloride, results in the formation of AgCl, silver chloride, which we have represented by down arrow. Which we have represented with down arrow. See here, this is down arrow. If you observe, here I have given, then along with silver chloride, sodium nitrate also formed. This here, what is the precipitate here? This AgCl is the precipitate. This AgCl is the insoluble solid formed. In any reaction, such precipitate means insoluble solid is formed, then we will represent it with downward arrow. Then moving to the next one, when a base, insoluble base, how it reacts with an acid. Okay, like copper oxide, CuO, when it is reacting with hydrochloric acid, then we will get a salt, CuCl2 plus water. When a base is reacting with an acid, it results in the formation of salt and water. In the similar way, alkali means soluble base. Alkali means soluble base. When an alkali is reacting with an acid, similar case we will get a salt with acid, similar. Now, carbonate or bicarbonate. When a carbonate or else a bicarbonate, anything you can take. When a carbonate or a bicarbonate reacting with an acid, along, normally when a base is reacting with acid, we are getting salt and water. But when bicarbonate or carbonates are reacting, we will get, along with the salt and water, we will get carbon dioxide also, which we will represent. It is a gas, right? So we will represent it with upward arrow. So next one, so these are all about preparation of salts, normal salts or neutral salts we can call. These are the preparations for the different types of the salts. Then moving to the next one, action of dilute acids on salt. Action of dilute acids. Dilute acids means what, ma? Dilute acids we have discussed just now, means amount of acid. If it is less per unit volume, then we will call it as dilute acids. If it is concentrated, means more amount of acid is present per unit volume. Now, if you observe here, first one just now we have discussed, when a carbonate reacted with an acid, it results in the formation of, along with the salt and water, we will get carbon dioxide also. Similarly, if hydrogen carbonate, nothing but bicarbonate, just now we have discussed, when bicarbonate is reacting with an acid, it results in the formation of carbon dioxide along with salt and water. And also when sulfite, like Na2SO3, sulfite, when sulfites are reacting with acids, means sulfites are reacting with acids, we will get sulfur dioxide as a gas and water and salt. So, in these, different gases are releasing. Not only these, when normally acids are reacting with the metals, when metals are reacting with the acids, we have already discussed H2 gas is released, right? Different gases are releasing. Then how to find? What is a confirmation test, whether we are getting hydrogen gas, whether we are getting carbon dioxide gas, or whether we are getting sulfur dioxide gas. How can we confirm it, whether the given reaction, in the given reaction hydrogen gas is produced or carbon dioxide gas is produced or sulfur dioxide gas is produced? How to find? See, we are having 3 different types of confirmation test for hydrogen gas, for carbon dioxide gas and for sulfur dioxide gas. First one, in any reaction, in order to check whether we are getting carbon dioxide, whether carbon dioxide gas is released or not, first test is we have to allow the gas, carbon dioxide gas, to pass through it through a slake lime solution, which is called as CaOH taken twice. CaOH taken twice, we will call it as slake lime calcium hydroxide. When we are allowing the carbon dioxide gas to pass it through the slake lime solution, then we will get a milky white calcium carbonate. We will get a milky white calcium carbonate along with water. So, immediately when we are getting the milky white solution, which means calcium carbonate is formed, an insoluble solid which we will represent by downward arrow. If we are getting such color, then we can confirm that yes, in the given reaction carbon dioxide is formed. Now, this is confirmation test for carbon dioxide. In which reactions we will get the carbon dioxide, ma? When carbonates or bicarbonates, when they are reacting with the acids, we will get carbon dioxide. Now that carbon dioxide we can test by using slake lime solution. In the presence of that, we will get calcium carbonate, so that which is which will get the milky white color, so that we can confirm that carbon dioxide gas is produced in the reaction. Now, next one, when sulfur dioxide, in any chemical reaction, if sulfur dioxide is produced or not, sulfur dioxide gas is produced or not, how to check? Here we are having confirmation test that whatever the gas released, we have to allow it to pass through potassium dichromate K2Cr2O7, then orange color will turns into green color, which represents that sulfur dioxide gas is produced. Next, what is the remaining, ma? Hydrogen gas. How to check hydrogen gas test? For example, we are doing the reaction. In that reaction, we are getting hydrogen gas, and now we need to check whether hydrogen gas is produced or not. We have to take, for example, this is candle, burning candle. The burning candle we have to take near to the reaction chamber. We have to take near to the reaction chamber where hydrogen gas is produced. Then immediately you will find a pop sound. Immediately you will listen a pop sound which represents the presence of hydrogen gas. Okay, what three gases, how to do the confirmation test we have discussed. First one is hydrogen gas, second one is carbon dioxide, and the third one is sulfur dioxide. Simple, ma. For hydrogen gas, we will get pop sound when we are taking burning candle near to the reaction chamber where gas is produced. That means hydrogen gas is produced. Second one, carbon dioxide, we have to allow the gas to pass through calcium hydroxide solution, which turns calcium carbonate, means milky white color we will get. It confirms presence of carbon dioxide. And the third one, sulfur dioxide, we can check by using potassium dichromate, in which we will get the green color. Okay, this is all about confirmation test for these three different gases. Then moving to the next one. Here three important reactions, ma, which we have to remember, which is very important for the exam purpose. Definitely we can expect questions on these three. First one, when acid is reacting with the metal. When acid is reacting with metal, we will get salt and hydrogen gas. When acid is reacting with a base, we will get salt and water. And when acid is reacting with a carbonate or bicarbonate, we will get, along with salt and water, we will get carbon dioxide. These three are very important reactions. Next, now this is what we have discussed in the last class. This is what we have discussed in the last class. See, blue litmus turns into red. It means We have dipped the litmus paper in the acids. Red litmus turns into blue. It means we have dipped the litmus into a basic solution, means alkaline solution. And effervescence, still now we have discussed how to check the conformation test, how to do the conformation test for 3 different gases. First, how to identify the gas is produced in the reaction, that is due to effervescences. Means if effervescences are there, bubbles, gas bubbles are there, then we can confirm that some gas is evolved. Next, if any PPT is produced, PPT means precipitate ma. If any PPT, insoluble solid, is produced, then we will call it as such reactions as precipitation reactions, and the insoluble solid we will call it as precipitate. Then here I have given a revision slide for entire chapter. So what we have discussed in the first class, in the last class what we have discussed about the acids. What is the nature of acids, means what is the pH of acids? Generally it releases H3O plus ions in the presence of water and its pH is less than 7. Whereas bases, they will release OH minus ions, its pH is greater than 7. And we have discussed about different types of indicators. We have discussed litmus, methyl orange, phenolphthalein and pH paper. Then generally pH, if it is lying 1 to 6, we will call it as acidic. If it is 7, neutral, 8 to 14, alkaline. And just now we have discussed about the different salts formation and reactions, how metals will react with the acids, how acid will react with the bases, how carbonates and bicarbonates reacts with the acids. This is all we have completed. Now here I have given some questions. Try to answer those questions and let me know in the comment box. See, these are the different questions I have given it for you. Try to answer those questions, and that's all for today, and thank you all. Have a nice day.